Did I say that right? Megan and Logan. That was like a tongue, I don't know, it just didn't sit right in my brain. Okay, anyway, all right, we've got a couple things that are going on here, so let me explain to you for just a second. My board over there, and Megan, what I wrote down at the top of your notes is not correct. We are not doing 10 through 34, the evens, because we would like to do less problems than that. We're going to do these 6 problems, okay? So I picked out the ones that I liked, and we're going to do those instead of 10 through 34, the evens, okay? Those ones instead. Now, typically, I do section 1-3 and 1-4 on the same day, and it's a little bit longer. But I think what we shall do instead is just do 1-3 today and save 1-4 for tomorrow, okay? Or whatever day. Yes, it will be the same problems. Like we'll do these problems for 1-4, but I'm not going to go through the notes with you for 1-4 today. We'll save that for tomorrow. So just 1-3. It'll be nice and short. Yes, sophomores are going to be gone tomorrow. So what we might do is, like, depending on what time you guys get back, because I think you get back at 3. We might just like do whiteboards for the rest of the period rather than like starting a lesson when you guys get back or whatever. So that's what we might do. Yes, sir.
The homework is only 1-3 or both?
We're only going to do 1-3 today.
Okay.
Yes,
Today?
we're only going to do 1-3 today.
When you're done.
So tomorrow, not tomorrow. Tomorrow everybody's going to be gone tomorrow. Thursday we'll do 1-4. So you don't have to do 1-4 notes or 1-4 homework for tomorrow. Just 1-3. Okay? I just posted it up there because your note sheet, the back side of it is the 1-4 notes, which means
Save it.
don't lose it, right? Don't lose it. Just set it there. Or put it up there on this shelf, okay? So don't lose this note sheet. We're only going to do 1-3 this side today, so Megan, switch that. It's not 10 through 34. It is just those problems, but we're only doing 1-3 today. You don't have to do 1-4 yet. We will get to that, okay? But 1-3, those 6 problems are what you're going to do for homework. 6 problems, not too bad, right? Okay, 1-3 is all about rate of change and slope, okay? Those two kind of mean the same thing. Rate of change is kind of the same thing as slope. This whole chapter is about linear functions, okay? And you remember linear functions was like lines that look like this. And we're trying to find the slope of that. What does slope mean?
Change. Yeah. Or like
Yeah.
how much it changes
Over, yeah.
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 It
The
has
slope.
rate of
So like this slope might be like a slope of 3/4, right? If I start here and I go to here, it's going up 3 and over 4, right? Like a slope of 3/4, we call that the m value. Slope a lot of times is represented as m, okay? So 3/4 versus like a slope that looks like this, right? This slope is gonna be negative, and maybe it's like negative, I don't know, down 1 and over 1/4, negative 1/4, right? It's going down 1 and over 4 from each point, from one point to the next point, right? Down 1 and over 4, that would be a slope of negative 1/4, right? Okay, so slope is like the degree at which it's like rising and running, you know? Because slope is the rise over the run, and if the rise is going down, then it's a negative rise, right? It kind of seems weird, right? It's a negative rise. So rise over run. Now, that is the reason why we do the y variable on top, right? Rise has to do with the y variable. The x's are the run variable. So the x's go on the bottom. Rate of change, okay? I'm going to put m next to this because a lot of times we call that slope our value of m. M is the variable that we use to represent slope or rate of change. Happy with that? Not too bad. Okay, so we've got this scenario going on. It says the table shows the temperature of a solution after it has been removed from a heat source, okay? Find the rate of change in temperature of the solution. So here we go. We've got this stuff going on. There are decimals here if you can't see those very well. I don't know, like that's 143.6 degrees Celsius, which is pretty warm. It's like water boils at 100 degrees Celsius. You knew that, right? Which is like 212 degrees Fahrenheit-ish. Okay, so it's pretty warm. It's pretty warm. This is maybe like 300 plus degrees Fahrenheit. So it would be like the temperature of inside your oven maybe or something. I don't know. Anyway, so 143 degrees is when I remove it from the heat source. Okay, now we're not taking this temperature consistently, right? We're waiting 2 minutes here versus 3 minutes. And then another 3 minutes later, and then another 4 minutes later. So we're not doing it every minute, or every 2 minutes even, or every 3 minutes. It's kind of like varying how often we do it, right? Do you see how I got those numbers? Okay? All right, so what we're looking at is like the rise or fall, in this case, of temperature over time, right? So here's how we do this. We take the second one and we subtract the first one. So the first thing that I'm going to do is I'm going to take 139.4 and I'm going to subtract 143.6. And if I do that, I get a negative number, which means it's gone down in temperature, right? Like negative means it's going down in temperature. That should make sense, right? Somebody want to do that for me? What is 139.4 minus 143.6? What do you get? I think it's like negative 4.2. Hey, negative 4.2, okay? Now, we want to also take into consideration the amount of time that has elapsed. So I'm going to divide that by, what do you think? I'm going to divide that by 2. 2 minus 0, which is 2, because 2 minutes have elapsed, right? Which means that if I do negative 4.2 divided by 2, that is going down 2.1 degrees per minute. Does that make sense? Down 2.1 degrees per minute on average is what it's doing, okay? All right, we're going to do the same thing for the next one, okay? So I'm going to do this loop right here. So I'm going to do 133.1, and I'm going to subtract 139.2. 139.2. 0.4, not 2. I'm making up numbers, sorry. And I do that, what goes on the bottom? Yeah, 5 minus 2, which is 3, right? 3 minutes have elapsed in my second time interval, right? Okay? And if I subtract those two, 133.1 and 139.4, we're still going down, but this time we're going down 6.3 degrees. You can check me if you don't believe it, okay? What is negative 6.3 divided by 3? Negative 2.1. So it's still going down an average of 2.1 degrees per minute, right? Make sense? Yeah? Yeah? Okay. All right. The next group, I'm going from 126.8 to 133.1 over, what goes on the bottom? 8 minus 5. We're going over another 3 minutes the next time I measure. Okay, and if I divide if I subtract those, another negative 6.3, and if I divide those, negative 2.1 degrees per minute. Hey, I'm guessing, if I had to guess the next one, I'm guessing it's gonna come out to be about that much. Okay, 118.4 and 126.8, we're subtracting those two guys. And on the bottom is 12 minus 8. This time we're going over the period of 4 minutes, okay? And it's not going down 6.3 degrees. It's going down 8.4 degrees, which averages out to be, hey, negative 2.1 degrees per minute, right? So our average rate of change, the rate at which the temperature is changing with respect to time, is it's going down 2.1 or a negative 2.1 degrees per minute. Okay, it's going down 2.1 degrees per minute. That is like the slope at which it's decreasing. Okay, now before we go to the next one, I'm just going to ask you some questions about this. Will that temperature continue to decrease at negative 2.1 degrees per minute forever?
No.
How come?
What happened to temperature?
It's been
like 30.
It asks too many questions. It'll what?
It will get closer to room temperature for the first time.
It'll get closer to room temperature. It took us a while to figure that out, right? They're like, oh, but it's gonna level out at like 0. I'm like, but is it gonna level out at 0? Like, will it get, because 0 degrees is actually, 0 degrees Celsius is like negative 32 degrees Fahrenheit. So like, is it still gonna, like, if I have a beaker sitting here, is it gonna get down to like a negative temperature? Like, no, it's gonna level out at room temperature, right? That's like why we use a refrigerator. Like the temperature of that room, we put stuff inside of it and it's gonna make it colder. Okay, you guys gotta go. I'll send him when I'm done. No, you're being too noisy. Go. Get out of here. Goodbye. 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 They're being too noisy. Go, go, go. Or I'll send him later. Okay.
This is Bokelman's fault, not ours.
All right. Example 2. Here we go. The average rate of change. Now we're comparing two different things. So we've got digital music going on here, and it is increasing at a really nice, good, steady rate. But then we have, you can't even really see it, ebooks. Like, it's kind of increasing a little bit, but not as great as what, like, digital music is. Do you think that makes sense? Like,
yes,
ebooks?
It makes a lot of sense.
Yeah, people aren't reading books as much? Come on. Okay, whatever. Digital music. All right, so let's find the rate of change. So Digital music. Let's start digital music. Here we go. And what is, so we're going to subtract these things. Digital music, the ending value is 3,100, right? The starting value is, do you see it? 200. Okay, so we're gonna end with 3,100. So we do that one minus the 200, right? And then what do we divide by on the bottom?
2000.
Nope, not yet, because we're only doing digital music right now.
Oh.
2009 and 2004.
Yeah, 2009 minus 2004, the time period basically. Okay, 3,100 minus 200 is like 2,800. No, 2,900. I did that last period too. I don't know why I can't math. 2,900 divided by 5, right? 2,900 divided by 5. Can you do that in your head? 5.
No.
40 is 8. 580. $580 million per what? Year. It is increasing at an average rate of $580 million a year. That's what digital music is like increasing by, according to this graph. Okay. Now, if we do, what's the other one? Ebooks. I'm going to do EB. Ebooks. Let's see how this works. Okay, our ending number, 165.8, and I'm going to subtract. What's that first number? Can you see it? 9.6 over the course of 2009 minus 2004. So still over the course of 5 years, right? And that is, I don't know for sure, 150, I don't remember, 156.2. No.
There was
It,
a council member
blah, blah.
meeting in the announcements for tomorrow morning. That
Check me.
meeting is canceled. There will be no
156.2.
students.
156.2
tomorrow.
equals,
That meeting will take place on Friday during fifth period.
If we divide.
Also, there will be a one-act meeting tomorrow morning. That's for all cast and crew at 7:35 in Mrs. Otten's room. Teachers, please dismiss the junior high volleyball players.
I was wondering why she's announcing, sorry. So that one is only increasing at a rate of $31.24 million per year. Not as great as the digital music. So we can use that to compare, right? Okay. Now, if you notice, what we did here, when we were like doing these things and when we were subtracting even up here, we were taking the second y coordinate minus the first y coordinate over the second x coordinate minus the first x coordinate, right? We took this one minus this one, the second one minus the first one, this one minus this one, the second one minus the first one. That's the way that it works when you're doing slope. Y2 minus y1 over x2 minus x1. This is the rise over the run, right? Have you heard that before? Y2 minus y1, x2 minus x1? Yeah? Okay. All right, so let's do some of these problems. These ones go a little faster because they're not story problems. So here we go. We're finding the slope from -4.3 to 2.5. And the slope is y2 minus y1 over x2 minus x1. You don't necessarily have to write that down again if you don't want to, but there it is. Okay. Now, what is my second y coordinate, though? 5. Okay, so it goes x and then y and then x and then y, right? This is your first x, this is your second x, this is your first y, this is your second y. Does that make sense how that works, right? So your second y will be 5 minus 3 over 2 minus a -4, which is 2 plus 4, okay? So 5 minus 3 is 2. 2 plus 4 is 6, and then we reduce, and it is 1/3. So that slope is going up 1 over 3, up 1 over 3, up 1 over 3, right? Make sense? Good? Okay. Now they say they want us to find the slope of this thing, and they're giving me a line. Okay, now remember, slope means rise over run, right? Is it rising? I mean, it still has a rise, but it's not going up. It has a negative rise, okay? So how do we find the slope of this, like the rise over the run?
You find 2 points and then you do the thing.
Okay, yep, and then you do the thing. So which 2 points would you like to use?
0 and negative, what is that, 4?
-3. 0, -3. And I think -2, 0 is a good one, right? You see those 2 points right there? You could have picked this one up here also. We didn't, but yeah, you could have. Okay, so I'm gonna pick those 2 points. And then we kind of like make a triangle between them, right? Like we do one of these and one of these, and we figure out how much we are going down and how much we're going over, right? So how much are we going down? Down 3. So we put that as a -3 over 2. And then what? That's our slope. That's it, right? That's all the slope is, right? That's like kind of nice, right? If you can reduce, but don't change that to a mixed number, -1 and 1/2. Okay, one more thing, real quick. Sorry. You have a problem like this on your homework assignment, and they say, what's the slope? 2x minus 3y equals 6. And they say, what is the slope? Yeah. Right. What is the slope? Okay, so here we go. Have you guys heard of like y equals mx plus b before?
Yeah.
If it's written in y equals mx plus b form, which one is the slope? The m, right? Okay, so can I make this y equals mx plus b?
Yeah.
Sure I can. Let's solve for y. So let's move the 2x over. Minus 2x minus 2x. Okay, 3y equals negative 2x plus 6.
Yeah, it's negative 3y.
Oh, it's negative 3y. Oh, okay. I was checking to see if you knew the difference.
Oh, okay.
All right, haha. The negative goes with the 3, not the 2, right? Okay. A lot of algebra kids like come and they're like, I want to add this 2x because it's a negative 2x. No, it's not. This is a positive. That's a negative. So the negative still goes with the 3. All right, now what?
Divide by negative 3.
Divide by negative 3. Divide by negative 3. Divide by negative 3. So last thing, y equals what's negative 2x divided by negative 3?
2 over 3. No.
Yeah, you're fine. 2 over 3. The negatives switch, like the negatives cross out. And I slide the x off the top. So to the side. And then 6 divided by negative 3? Negative 2. So what's the slope? 2/3. The slope equals 2/3, right? Do we know how to do that? Sure. Okay, there you go. That's all. Whew! 6 problems for homework. Man, oh man. Toby, you better go. They're going to yell at me.
You're welcome.
Again.